Let us find out domains and ranges of trigonometric functions. You can see that the first function is sin x. Take right angle triangle. This is theta. This is the opposite side. This is the adjacent side. This is hypotenuse. In this, for this theta, x can take any values. Sin x is opposite by hypotenuse, implies you observe that opposite side is always less than hypotenuse. Opposite by hypotenuse is less than 1. That means sin theta will be always less than 1. Depending upon quadrants, first comma second quadrant, sin theta is positive. Third and fourth quadrant, sin theta is negative. Therefore, sin theta is always a proper fraction. It lies between -1, 1. That means -1 less than or equal to sin theta less than or equal to 1. Now, let us do cos theta. In the same right angle triangle, opposite, adjacent, hypotenuse. Cos theta is equal to adjacent by hypotenuse. Again, adjacent side is less than hypotenuse. Adjacent by hypotenuse is always less than 1. Again, cos theta is positive. That means cos theta is less than 1. Cos theta is positive in first comma fourth quadrants. Negative in second comma third quadrant. Therefore, -1 less than or equal to cos theta less than or equal to +1. So, sin theta and cos theta are proper fractions. Let me take up secant theta. Secant theta is 1 by cos theta. If cos theta is proper fraction between -1, 1, secant theta is reciprocal. It lies between minus infinity to -1 union 1 comma infinity. All improper fractions. Similarly, cosec theta is 1 by sin theta, improper. So it lies between again minus infinity to minus 1 union 1 comma similarly 1 to infinity. So sin theta and cos theta are proper fractions. Its reciprocals are improper fractions. Next, tan theta, cot theta. Therefore, in tan theta comma cot theta, opposite comma adjacent can be any numbers between minus infinity to infinity. Therefore, tan theta comma cot theta are any numbers between minus infinity to infinity. Therefore, range is capital R. Now, see the domain here. Here sin theta can be anything, positive or negative. X theta values are real numbers. But sin theta values lie between minus 1 and 1. Same is the case with cos theta. Tan theta. I discussed only range for tan theta. Let us discuss the domain here. Tan theta implies sin theta by cos theta. Implies cos theta should not be 0. Cos theta is equal to 0 when theta is equal to pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2, etc. So odd multiples of pi by 2. So cos theta is 0 when it is this. Therefore, domain is r minus 2n plus 1 into pi by 2. N belongs to Z. If you take cot theta, if you take cot theta, it is cos theta by sin theta. So this implies sin theta should not be 0. So sin theta is equal to 0 when theta is 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi, etc. Therefore, domain is r minus n pi. For cosec theta also, domain is same. For secant theta also it is r minus 2n plus 1 into pi by 2 because it is 1 by cos theta and cos theta not equal to 0.